hyperbola. It's created by you're rotating a hyperbola all the way around to make a three-dimensional object. Like a paraboloid would be a three-dimensional satellite dish, right? It's in the shape of a parabola, but it's 3D, so you call it a paraboloid or a hyperboloid. Rotating a hyperbola around its conjugate axis. Suppose that a cooling tower has the following dimensions. So its base diameter is 400 feet. The diameter around its narrowest point, which is 360 feet above the ground, is 200 feet. And the diameter at the top of the tower is 300 feet. Based on the picture first, is the hyperbola vertical or horizontal in orientation, do you think? What does it look like? Huh? It's horizontal, right? Because you've got your curves going this way. Do you see your two curves? Right? So that's step one. I know that it's horizontal, right? So it's going to be x squared going first, right? Because this is my axis right here. So then it says the narrowest point of the tower will help you figure out the A value of the hyperbola, right? Because at its narrowest point, that's going to be like if it was right here, the narrowest point, the middle of that will be your center, right? And then your A value will find your two vertices of your hyperbola. So it says what? The diameter at the narrowest point, which is 360 feet above the ground, is 200 feet. So do you see where that is? This right here is 200 feet. Oh, you can't see my red line, but what does that tell you the A value has to be? Half of that, right? Right, because I have to walk from, if this is my center, I have to walk 100 and 100 in either direction, right? So A must be 100. Write an equation for the hyperbola before it's rotated. Let the base of the cooling tower, so the base of the cooling tower right here, is on the x-axis, and use 0, 360 as the center of your hyperbola, right? Because it said that the center up here is located 360 feet off the ground. So they're helping you with what your center is. You will have to solve for B in the equation by substituting in the coordinate lying at the base of the tower. So let's write what we know so far. We know that x squared has to go first, right? Because it's horizontal. And we know that if our center is at 0, 360, right, we just need to write x squared minus what? How do I shift it up to 360? In my y coordinate, what am I going to write? Y minus 360, right? So doesn't that put my center at 0, 360? I'm going to write equals 1 over here because this is a hyperbola. And now I need to figure out what I put in the denominator of my fractions. All right, what was my A value? My A value was 100, we decided, right? Because that's what we found was the half of this width. So I'm going to put 100 squared in the denominator, right? So 100 times 100 would be a 1 with 4 zeros. I need to solve for B. So I'm just going to write B squared down here. What point do I have to substitute in for x, y? So let's go back up here. It says the base diameter, right, was 400 feet. So that is this, the base of this cooling tower had a diameter of 400. What is this point at the base of the tower that I can substitute in? Because my hyperbola passes through this point at the base of the tower. So what point should I use? This is the x-axis, right? So what point should I use to substitute into the equation? This is the x, this is 0, right? Yeah, 200, right? They say the diameter is 400. Base diameter is 400, so this is the point 200, 0, right? Because it lies on the x-axis and it's 200 units over from the center line. I'm going to plug in 200 for x and 0 for y and solve for b squared. See how you do on solving it. see if you can figure out the algebra steps, because we've solved similar equations when we've got fractions because of the bridge, right? So you're plugging in 200 here, so you'll have to do 200 squared. You've got 100 squared here, minus, this is just going to be 360 squared, right? Because y minus 360 is just negative 360. Square it, you're going to get the positive outcome. See if you can solve that proportion, right? Subtract one of the fractions to the other side. Cross multiply, see if you can get b squared algebraically for a minute. I'll show you in a minute anyway, but see if you can get it. And then we're going to use our equation to solve for the height of the tower. Notice this is really 4 minus 360 squared over b squared equals 1. So that's not too bad, right? Subtract the 4 to the other side, now you have negative 3. So you're solving negative 360 squared over b squared equals negative 3, which you could make negative 3 over 1, so you could cross multiply, right? This times this divided by negative 3. So you're really doing negative 360 squared times 1 divided by negative 3 gives you b squared. And you could just leave it as b squared, right? Because b squared is the number that's going to sit in your equation. And this negative sign is in front, so it's going to end up a negative divided by a negative. You should end up with a positive b squared value of 43,200. Does that sound right? So I took negative 360 squared times 1 divided by negative 3 to get b squared. So my final equation that I'm going to use is going to be this equation, but instead of writing b squared, I'm going to write, what was it? 43,200. So that's the equation of this hyperbola that I got by knowing the diameter at the center, knowing how high up that center point was, and one point that was on the ground. So see if you can now use your equation to figure out the height of the tower. And they give you one more clue. It says the diameter at the top of the tower is 300 feet. So what would I call this point right here? If this is 300, what x value is that? 150, right? So I have an x value of 150, comma y. I'm trying to figure out what y value will make the diameter 150. And there's actually going to be two y values that satisfy that, right? Because there'll be another one kind of down here on the lower part of the hyperbola. So whichever one comes out as the higher y value is the one that you'll want as your answer. So you're going to plug in 150 for x and see if you can figure out what y values will make this true. And then the y value is going to be the height of your tower. There's a lot of really challenging algebra, so you're not going to have a problem like this on your unit test, but I just want to show you there are real life hyperbolas, right? So they had to design these cooling towers. They probably modeled it with an equation to figure out the diameter of the tower they needed for optimal like cooling of nuclear stuff. I mean, that's pretty important, right, to get right. So you're going to plug in 150 for x. So 150 squared over 10,000 minus y minus 360 squared over 43,200 equals 1. So you're going to get rid of this fraction, right, to the other side. And then you could just make it the opposite to get rid of this negative sign. Multiply by 43,2. And then square root both sides. I'll give you a minute. I want to see if you can problem solve what the y value would be. You could even pretend you're solving for x and plug it into the y equals menu and see if you could get the correct x value, which in this problem is your variable. So this came out to right, 2.25 subtracted over, that's when we got that this fraction was equal to negative 1.25. Get rid of the negatives, multiply by that 43,200, and you get y minus 360 squared was it 54,000? And then we took the square root of both sides and added 360. So y had to be 592 as our final answer. All right, so this one says, have you guys heard of Rutherford from chem or bio? Pretty famous scientist. In May of 1911, Ernest Rutherford, isn't there like a Rutherford Hayes formula or something? Rutherford? No? I've got to look that up. Anyway, he published a paper in Philosophical Magazine in which he described the motion of alpha particles as they shot at a piece of gold foil that was however many 0.0004 centimeters thick. Rutherford expected the alpha particles would shoot through the foil like a bullet would shoot through snow. Instead, a small fraction of the alpha particles actually bounced off the foil. This led to the conclusion that the nucleus of an atom is dense and the remainder of the atom is sparse. Only the density of the nucleus could cause the alpha particles to deviate from their path. So the figure shows a diagram from his paper indicating the deflected alpha particles follow the path of one branch of a hyperbola. Find an equation of the asymptotes under this scenario. And you can see that this is one of the asymptotes, right? It's coming out from the origin, so that gives you a nice y-intercept. And if it has a 45-degree angle right there, what would be the equation of this line? 45-degree angle coming out of the origin has to be what? A slope of 1, doesn't it? Tangent of 45 is 1. So can't you just write it as y equals x or y equals negative x, right? Because the slope is 1, y equals 1x plus 0. And then it says if the vertex of the path of the alpha particles is 10 centimeters, right? This is the vertex of the path. It's 10 centimeters from the center of the hyperbola. So the center, right, is here. Find a model describing the path of the particle. So can you write an equation for these hyperbolas, right? The matching side of the hyperbola would be over here. We're just dealing with this one side, but you can pretend your hyperbola looks like that. So take a minute and see if you can write the equation yourself. You know the orientation of the hyperbola. You know the slope of your asymptote, so that helps you figure out your rise over your run. And you know where the center of your hyperbola is. And you know the A value, right? They tell you the A value in the equation. So take a minute, see if you can write the equation of this hyperbola. So we know it's x squared minus y squared because it's horizontally oriented, right? Equals 1. And we know the A value is 10 because the vertex is 10 units from the center, right? 100. And if this is 10, doesn't this have to be 10 so that your rectangular box was up 10 over 10? So B value is also 10, so 10 squared is also 100. This is not a circle, right? There's a minus sign. So, right, if it was a plus sign, it would be a circle, but the minus sign is a very significant part of your equation. So that's why I'm going to be a stickler in your equations on your quiz. If you're missing the plus or the minus sign, that completely changes what type of conic you have.